Our essential question is, how do we correctly diagnose which integration technique to solve problems? So I want to start off today with a little bit of review, if you will. And so I've got some built-in review where you guys are going to practice your derivative and integration rules. So for all of the examples in example number 1, I would like for you to find the derivative and do not leave negative exponents or complex fractions in your answers. So I want you to press pause, and we are going to take the derivative of 1a. Be prepared to type your answer into Edpuzzle. So using our power rule, we get 12x cubed. Remember that this is 2x to the negative 1, so using our power rule, we're going to get negative 2x to the negative 2. The derivative of 12x to the 3/4 is going to be 12 times 3/4. X to the, if we do 3/4 take away 4/4, we'll get negative 1/4. And I threw this on here to just try and trick you because that's just a constant, so that will be 0. We're not going to leave any negative exponents in our answer, so our final answer is going to be 12x cubed minus 2 over x squared minus 9 over the 4th root of x, okay? In 1b, I would like for you to execute a little bit of product rule. So press pause and take the derivative. Using our product rule, we're going to take the derivative of the first one and get 15x to the 4th, leaving the second one alone. Taking the derivative of the second one with some chain rule, so cosine of 2x times 2, leaving the first one alone. We are going to take out a GCF because there is a GCF in common between our first and second terms. So I can take out a 3x to the 4th. If I do that, I'm going to be left with just a 5 sine of 2x and a 2x times cosine of 2x, close the bracket, okay? For 1c, you guys are going to be executing a quotient rule. So let's see if we remember our quotient rule. Go ahead and press pause and do some quotient rule. We're gonna go low, leave it alone. Derivative of high, secant x, tangent x minus high. Derivative of low, 3x squared, draw the line and square the low. Let's simplify this a little bit. So let's take out a secant x. We'll have x tan x minus 3 over x to the 6th. And actually, I could have taken out an x squared with this as well. There should have been an x squared, my bad. And then let's actually reduce that x squared and the x to the 6th. That is totally my bad. So your final answer should have been secant x, I got ahead of myself, times x tan x minus 3 over x to the 4th, okay? For 1d, we are going to use our chain rule. So press pause and let's execute a chain rule. We're going to leave derivative of the outside 4. Take that down to the 3rd power. Leave your inside alone. Now multiply by the derivative of the inside. Make sure you're using parentheses here, 10x to the 4th. I'm going to write my final answer as 40x to the 4th multiplied by 2x to the 5th plus 3 to the 3rd power. The last derivative that we're going to do is going to be another chain rule. So I've got e to a power. Press pause and take the derivative of h of x. Remember that the derivative of e to the stuff is e to the stuff But now we're going to multiply by the derivative of stuff. So the derivative of sine will be cosine of x to the fourth, and then one more layer times 4x cubed. The pretty way of writing this answer would be to put your 4x cubed in the front, put that cosine x to the fourth in the front, and then your e to the power of sine of x to the fourth in the back. So that is our crash course review of differentiation. We now need to also review our integration rules. So let's do that. I'll do this first one with you. Remember that this piece right here, we're gonna write as 5x to the negative fourth power. So we need to be able to go backwards and forwards in our integration rules. So going to our first term, add a power, divide by that same power, add a power, divide by that same power, and the integral of sine is negative cosine x. Don't forget your plus c. Let's simplify this to be a final answer of x cubed minus 5 over 3x cubed minus 2 cosine x plus c. Your turn. I'll hint that on 2b, you are going to use u substitution, and I would like for you to change your bounds. Press pause. Let's make u x cubed plus 1 du 3x squared dx. I don't have a 3, so let's get rid of that 3. So we're going to write this with a 1/3 integral of u squared du. Changing our bounds, 1 cubed plus 1 is going to give us a new bound of, 1 cubed plus 1 should give us a new bound of 2. And then 2 cubed should give us a bound of 9 here. Taking the antiderivative, u cubed over 3, evaluated from 2 to 9. I'm going to leave my 1/9 on the outside. We're going to go 9 cubed minus 2 cubed, and that should be 729 minus 8 over 9 for a final answer of 721 over 9. You are also going to do u sub on something like 2c, so take a minute and give it a try. So let's let u be 3x. du would be 3dx. We don't have that 3. Sometimes we forget that we have to do u sub in a situation like this. So I've got 1/3 e to the u du. Remember that the integral of e to the u is just itself, for a final answer of e to the 1/3 e to the 3x plus c. You guys are going to do the definite integral on 2d. Press pause, give it a go, and then we'll check our answers. I am going to do this by changing bounds, so let's make u 3x. We'll make du 3dx. Divide by 3. So we're going to throw that 1/3 in the front. We've got sine of u du. Let's change our bounds. 3 times 0 is 0. 3 times pi over 6 is going to make that new bound pi halves. Our antiderivative of sine is negative cosine. Be careful going backwards and forwards in our rules. And now let's plug it in. I'll keep that negative 1/3 on the outside. Let's go cosine pi halves minus cosine 0. Cosine of pi halves is 0. Cosine of 0 is 1. Final answer is positive 1/3. 2 more to go. Still going to be u sub here, so you need to make sure you're very conscious of u sub situations like this. Let's make u 5x. du is going to be 5dx. Let's get rid of that 5. 1/5 integral secant squared u du. Let's change our bounds. 5 times 0 is 0. 5 times pi 20th makes our new bound pi over 4. Make sure you are linking your work. The antiderivative of secant squared is going to be tangent u. We're evaluating this from 0 to pi fourths. Leave the 1/5 on the outside. Let's go tan pi fourths minus tangent of 0. Tangent of pi fourths is 1. Tangent of 0 is 0. Final answer, 1/5. Final problem. By the way, there is a reason, excuse me, I lied. There's a couple more. But our reason for going through this process is actually fully intentional. Okay, we are going through this process for a reason. So for something like this, I hope you immediately caught that this is going to be an arctangent situation. If you're not so certain of that, it might be helpful to write the x squared plus 9 on the outside so you can see it. That's going to make my ux and my a3 so that du is dx. Keep your 4. Remember that arctangent has a 1 over a arctan u over a. Don't forget that plus c. Guys, I forgot that there was a second page of this, and I promise you there is a method behind my madness here. So these are the spicier examples. You'll notice that I have again juxtaposed those 3 questions side by side where they look very similar, but they are not. So this one ends up being arctan. So diagnosing these, definitely important. When I look at something like 2g, I'm thinking, can I u sub it? And sure enough, you can. So we're going to make u x squared plus 9, which is going to make du 2x dx. I have a 4x, so if I hit both sides with a 2, I'm going to have 4x dx, which is what I wanted. Rewriting this thing, going to have a 2. 4x dx is going to become 2 du, and my bottom is just du over u. Okay, integration rules. Integral of 1 over u, 2 times the natural log. Don't forget the absolute value of u plus c. Your last step is to throw the u back in. So I'm mixing in a little bit of definite integrals, a little bit of indefinite integrals. Similar problem. But now I've got a 4x squared. Now this is the situation where I can't u sub it. It's not arctan. So we're going to divide, guys. I'm going to take that x squared plus 9 as my divisor. I forgot my placeholders. Come on, Lowry. Plus 0x plus 9. We're going to be dividing 4x squared plus 0x plus 0. X squared goes into 4x squared 4 times. Now let's multiply. 4x squared, 0x, and 36. Subtracting is going to give us a remainder of negative 36. All right, so we've got a remainder of negative 36, so we're ready to rewrite this thing. I'm going to rewrite this as the integral of 4 plus negative 36 over x squared plus 9 dx. And now we're going to split this into 2 integrals. Let's go 4 dx. Let's take the 36 to the outside. And we're ready to go. The antiderivative of 4 is just going to be 4x. We're going to keep our 36. I hope you see this is arctangent. You need to start making sure you see those things where u is x and a is 3, which means du is just dx. So we're going to have a 1 over a arctangent u over a plus c with a final answer of 4x minus 12 arctangent of x over 3 plus c. Moving right along to something like 2i. Again, I told you these are some spicier examples, so let's look at it. So something like this, u sub doesn't work. So we need to do a little bit of side work over here. I'm going to rewrite this as negative x squared minus 2x plus 8. We're going to complete this square. Let's take out a negative, but only from the first 2 terms. To figure out what number completes a square, we're going to take our b, cut it in half to get 1, and square it. But remember, that's not really a 1. It's really a negative 1, which means to balance this needs to be a positive 1. If I factor this, I now have negative x plus 1 squared, and 8 plus 1 is 9. Now that's going to help us because when we go to rewrite this integral, it is now the square root of 9 minus x plus 1 squared. That order swap is definitely going to be helpful because now that I've swapped the order, I can see that u is x plus 1. I can tell that a is 3, and this is an arc sine. Arc sine is the only one that doesn't start with a 1 over a. So we've got arc sine u over a. Slap that plus c on there. Almost done, guys. We're going to complete the square on this one on the bottom as well. How do I know that? I know that because it's not u subbable. So we're going to take that x squared minus 6x. Let's bring in a new c value. Taking our b value here in the center, cutting it in half and squaring it, we should get 9. So I'm going to have a positive 9 and a negative 9 factored into our equation. This is going to factor into x minus 3 squared, and 34 minus 9 is conveniently 25. So rewriting this, I'm going to have dx over x minus 3 squared plus 25. Do you see it? Do you see it? What is it? What is it? That makes our u x minus 3. That makes our a 5, and it's an arctan. So I've got 1 over 5 arctan u over a plus c. The last one that I'm going to have you do is going to be 2k, and my caution to you is this is going to require a little bit of work. So I'm going to challenge you to do 2k by yourself completely. You're going to have to complete a square. You're going to have to do some u sub. Do it. Let's go. Okay. So I can tell that maybe if I u sub 2x plus 4, but I don't have 2x plus 4. I have 2x plus 7. So we're going to do something kind of slick. We're going to have that x squared plus 4x plus 13. And I'm going to have my 2x. But instead of 7, I'm going to put plus 4 plus 3. Now that's still 7. I haven't altered the fact that that is 7. But what this enables me to do is to now split this into 2x plus 4 over x squared plus 4x plus 13 dx. And then I'm also going to have 3 over x squared plus 4x plus 13 dx. Now the integral on the left is u subbable. It's going to be 1 over u du. But the integral on the right is going to require just some more work. So we're going to take this over here, and we're going to complete the square with it. 4 cut in half is 2. 2 squared is 4. So that's going to be a positive 4. This is going to be a negative 4. Factoring this, I get x plus 2 squared, and 13 minus 4 is 9. So rewriting my second integral, let's take the 3 to the outside. I now have 1 over x plus 2 squared plus 9 dx. Do you see that arctan? Taking my antiderivatives, I've got natural log absolute value of u. I've got a 3 here. My u is x plus 2. My a is 3. So when I take this antiderivative, remember that arctan has a 1 over a, so 1 over 3. Arctan u over a. Don't forget your plus c. We're going to write our final answer. natural log, absolute value, x squared plus 4x plus 13. My 3's are going to go away, and I've got arc tan x plus 2 over 3 plus c. Now, if you got all the way through that, you nailed it. That's awesome if you got that answer. We're going to stop there. We're going to come in next time, and we're going to talk about why I just did 3 pages of review with you, because it's going to be needed when we dive into this integration by parts. Let's go.